Bismillahir Rahmanir Rahim. Welcome back, um, and congratulations on passing the LCA course, the prerequisite to this course. Although this course is named Electrical Network Analysis, but it should not impress you that we are going to study something else. It is still linear circuit analysis. The circuits are that we are going to study in this course will be linear as well, and it is just a different name for them because whatever we have studied earlier in LCA were also networks, and those that will be studied here in this course will be networks as well. In LCA, we usually solved circuits using sources that were DC. So we used, for example, this symbol to represent a DC voltage source. And if we plot such a DC source against time, so basically the value of the function of voltage of time, the function of time, the voltage across this source was a constant. So t is equal to 0 is the time usually when our interest in a circuit starts, and then it's a constant that goes on with time. So they were constant voltage sources. But here in this course, we will begin our study by looking at sources that we use every day, and they are used all over the world, and they are known as sinusoidal sources. So, for example, um, you should be able to recognize this function. So, if Vt is such a function and this goes on forever, then we understand that mathematically, if this function is an eternal function that starts from minus infinity and goes on up to plus infinity, then Vt is equal to, this is how it is defined, is a cosine function. So cos of t, where t is the time, is what this function is. So we call this sinusoid because a cosine function is actually a sinusoid as well. So sines and cosines are sinusoidal functions, and the symbol that we are going to use for this source will be these plus minus signs with a sine wave here. So this is going to show that this is an AC source. So we will start this ENA course with the study of circuits with AC input, uh, AC sources. So similarly, if this would have been a current source, then we used to represent it with such a symbol, and it would be a constant value. The function here would be something like this: Vt is equal to, say, capital Vs, the source voltage. And usually we use capitals for constants and small letters for variables. So here we used to either write number or capital letters to designate their values. For example, IS for current source. But here we will be using small v's, and for current sources we will be using small i's and the t to signify that they are functions of time. Sometimes we specify and explicitly write this t, and at other times we skip it. So whether it is simply a v or an I or a VT or IT, it is still the same thing. It is just a convenience that often comes into play. Okay, so if we have a circuit like this, so we have a DC source, and then say we have a purely resistive network all resistances. From our current knowledge or the knowledge attained up to now, we can find various currents and voltages in this circuit. And if this is not a purely resistive circuit or a purely resistive network, but we have other elements in it as well, say it is an RLC circuit. So we have an R, say 3 ohms, and an inductor of say 0.5 Henry, and say a capacitor of 5 millifarad, and then a constant voltage source of 10 volts. We have learned how to evaluate this in the presence of switches, or the step function to describe the switching part. We can solve this. We know how to solve this. We can solve this. But what about this? That suppose we have the same circuit, the RLC circuit, and this source here is not a DC source. Instead, it is, for example, say, okay, a pure cosine function, cos t, and this is that 3 ohm, this is 0.5 Henry, and this is say 5 millifarad. So if we are to find say the current in this circuit, IT, and the current in this circuit, I, the same thing, how we are going to proceed with this? So if you remember, for RLC circuits, we used to find its nature of the response based on the component values, whether they are overdamped, underdamped, or critically damped. And then from there, we used to write the expression for the function for the thing that we want to find, and then solve for the various constants in that expression. So for a overdamped system, this IT may come out with something like IT is equal to a final value plus the response of this type A1 e raised to the power S1t plus A2 e raised to the power S2t. Now this IF, this A1, A2, S1, S2, these 5 things, when these are known, we have found the expression for IT. So what about here? So how will IT look like? Is this same method applied here, or we need to develop different methods, new methods to solve this type of circuit? Is what we are going to start this course ENA with. So only one thing is changed, the source type. The circuits, although in LCA we used DC sources, but there were a very small group of circuits or classes of circuit that we could solve. So for example, we can solve a series RLC circuit, but we may not be able to solve this circuit. The knowledge that we acquire in LCA would not even help us solve this one. It's not going to be very easy. So we only dealt with series RLC or parallel RLC, but this is neither series nor parallel RLC because of this is a capacitance, this is a capacitance, and they are not in series, not in parallel. So we cannot actually resolve this into a series RLC or parallel RLC. So it's not easy for us to solve this even with LCA knowledge, even though this source is a DC source. So we need some newer methods that can even help us solve this one. But we will begin with the analysis of circuits where the circuits have AC sources and some RLC, any of the or all of the RLC components, and even such type of circuits or networks can be entertained as well. So let me remind you that this course is not something totally new, so that you can throw your knowledge acquired in LCA out of the window and then start cramming things in this course. If you don't understand LCA, if you were bad in that and somehow have managed to get to this class, you should first develop conceptual understanding of LCA and then move on to this course. So while solving such circuits, we are going to deal with all those basic laws and rules that we have studied there in LCA. So for example, the passive sign convention is at the core of everything that we do. So passive sign convention, that when the current enters something from the positively marked terminal, then the voltage across that something and the current through that something, the expression for that voltage or current as a function of say current, as a function of current, gets a positive sign. So for example, if this is a resistor, then this V will be equal to R, positive sign Ri. So I, the positive value of this I, the value of this I and the value of this V, whatever, whether they are positive or negative, would be related by a positive sign in the expression. So this is passive sign convention, and the passive sign convention is at the core of everything that we study. What next? We will be dealing with Kirchhoff's voltage law, Kirchhoff's current law, all applicable to the circuits that we are going to study in this course as well. So whether the source type is DC or AC does not matter. The laws hold. And then everything that we have studied in LCA would also come in handy in here as well, all the laws at least. So the node voltage method is still applicable here. The mesh current analysis method is still applicable here. So the Ohm's law, let me just write them here under this, in this group 1. So the Ohm's law and all the relationships between V's and I's for different elements come in handy in this course as well. So if you remember, this expression dealt with an inductor. The voltage across an inductor and the current through that inductor are related in this fashion. And similarly, I is equal to C dV by dt is something that relates to a capacitor. So if this is the V, this is the I, when the passive sign convention is fulfilled, then I is equal to C dV by dt, positive sign here. Again, we are going to use them in every circuit, in everything we do. So understanding these crisply is very important in understanding this course. You cannot pass ENA if you don't have good concepts of LCA. So that is how things go on in a degree. You learn the first semester courses, you have to learn well, because the second semester is going to build on those. The third, the fourth, up to the 8th semester will still be using the core concepts learned in the first semester. That is why you cannot cheat your way through. That is why you should not be worried about getting marks just by copying assignments. You should be worried about your own learning. You should be worried what I have learned. Ask yourself this question, that if I just copy this assignment, am I going to learn something? If you don't learn by doing something, why do it? And you have had a flavor that if you don't learn the concepts, you are not going to get through in this course. While I may be a bit lenient in noting copying in assignments, I would not be lenient in noting cheating or plagiarism attempts in final exam. And we are beginning this semester online, but soon we are going to meet in class, and all the assessments are going to take place in the class. However, whatever I am going to teach in these online lectures are not going to be repeated in class, because they will be recorded in video, and you can always watch these videos at your free time to cover whatever this stuff is. A few things about this course with this brief explanation. And let me add another point before moving on to some basic things about this course, that if this type of the source is further changed, so it is not a DC source, it's not a sinusoid, say it is something like an exponential source, e raised power minus 10t ut. Now you can see if we plot this function, it is an exponentially decaying function. It starts at t equal to 0 because of this ut, and e raised power minus t starts when t is 0, e raised power 0 is 1. It starts at 1, it decays exponentially and ultimately becomes 0. So if we have such a source in this circuit, how to solve it? So in this course, essentially, we will start the analysis by considering pure sinusoidal sources, and then ending this course by studying a technique that is so general that it can handle DC sources, it can handle sinusoidal sources, and it can handle any type of source. For example, an exponentially decaying source. And that technique is basically what is the ultimate objective of going through this course. So in this course, we are going to have 4 CLOs. Now, you will get a document uploaded on the Google Classroom for this course, and there are 4 CLOs in it. The first CLO deals with exactly this thing, the study of circuits with AC source. And there are certain types of circuits that we will be specially studying. So that would be the CLO1, and we will take around 6 to 7 weeks to cover that. And then we will introduce a transformer in the circuits that we have studied. So when this AC source comes into play, there is a device, electrical device known as a transformer, that can transform voltages and currents. And you are already familiar with this word because everybody knows that in summer those transformers often go crazy, and there are these big boxes placed at the corner of a street on a pole, maybe, or between two poles, or in a big box on ground. So when these transformers come into circuit, how are the circuits going to react or act? So we have to study that. So this is CLO2. And then we will come to that general technique. The technique is known as the Laplace transform based technique for circuit solution. And this, I would say, is the main objective of this course, to understand this technique of circuit study. It's not that this is not important. In fact, these are the 2 most important CLOs in this course. And then the 4th CLO is, we have a special type of circuits where, instead of worrying about what is going to happen to the output of a circuit at a certain time, we are more concerned about what kind of input signals or sources get easily transferred to the output and what are blocked. So there are circuits that allow certain type of input sources to have a larger output, and certain type of inputs to have a smaller output. So we are going to look at those circuits, and those circuits are known as filters. Remember what a filter does? A filter takes in several things, stops some, allows some to pass. So a filter in circuits is a circuit that has several components in the source that is supplying it at the input, but only some type of input components are allowed to pass with a higher amplitude, and others amplitude is severely attenuated or reduced. So this is a very important application. It is more of an application for what we have learned about circuits, and we are going to see a class of circuits that react differently to different frequencies. And this word frequency, as you understand, represents change, comes into play when we are dealing with AC sources, because here we are experiencing change. So if this change is slow, we have a lower frequency, and if this is fastly moving, a changing signal, then it has a higher frequency. So some circuits allow lower frequency sources to have a larger output, and some circuits have fastly changing or higher frequency sources or inputs to have a higher output. So we are going to study this, and this would be in a way our actual use of the knowledge that we have acquired in LC and electrical network analysis till now. And transformer obviously are also in a way an application, although we will learn new things in studying all these CLOs. So you have to pass all these CLOs to clear the CLOs. Remember, in OBE, in objective based education, you should not only be concerned about passing a course, but also clearing all CLOs. And the document on the Google Classroom that I am going to share about the CLOs and the course outline is going to specify some rules and these CLOs as well. And you should give a thorough read to that document. So in that document, it's mentioned that the grading scheme I would be using, would be IQR, the interquartile range method, or as you are already familiar with. So this grading scheme is how we are going to grade your marks at the end of the semester, and it is well documented, and you should have a good understanding of that. But again, this IQR is going to give you a grade, not make you clear the CLOs. So you yourself have to understand that each CLO must be cleared, means you should not be developing this strategy to clear this course by say, okay, spending more time on CLO 1 and 2 and ignoring 3 and 4. So if you ignore 3 and 4 and just spend time on 1 and 2, you may pass this course. But that's not the objective of an OBE education system. You have to clear all these. If you don't do this, then you even after this semester is over, you will be given assignments and held quizzes and other assessments unless you clear all the CLOs. So work hard and clear it right now, instead of lacking and lagging, and then later on with other courses you have to cover these past material as well. So this is very important. So as an advice I would give you, do not try to copy, do not try to do something without putting your brain to it. Even if you want to do a combined study or discuss something with someone, discuss it and then try to see what you have learned, and then do some different questions based on the learning acquired, the concepts. If you do, if you work this way, I assure you that this is not a difficult course. But if you don't do this way and you keep on working with the strategy you had, most of you had in LCA, unfortunately, ENA is a tougher course as compared to that LCA. So you have to spend much more time polishing your concepts than actually worrying about the grades you are going to get. And these grades are not going to help you much in your practical life. When you are on job, grades no longer help you. And they are the concepts that basically keep you in the job. So while grade may get you a job, although I disagree with the statement, but if you think grades are important to get a job, concepts are what keep you there. So that's very important. And in the marks distribution, I am going to follow the simple scheme that assignments plus quizzes together are going to contribute to 20% of the marks. And then we are going to have a midterm. The midterm is going to contribute to 30%, the ninth week of the semester or so. And the final exam is going to contribute to 50% as is required by the Pakistan Engineering Council. And this is a breakdown of the total marks in the course. How much would the assignments value and how much would the quizzes weigh is something I am going to describe later. However, I would not be giving any, I would not be taking any quiz during this online education. We are going to hold the first quiz on the first day. Probably we are going to meet on campus, and the assignments would be given, and the marks of the assignments wouldn't be very wouldn't be significant in playing a role in your overall grade. So you should try to do the assignments yourself. Assignment, if you ask me, assignments are the the only method, the only device, the only tool. Assignment is the only tool that helps you actually learn. By lecturing, you only gather 5 to 10%. And assignments are actually the tool that helps you learn the most. And if you cheat through an assignment, you have wasted that most important tool. So give good consideration to assignments and try to do it yourself. Even if you cannot do it, do not cheat. I hope you will follow this. So I am trying to keep these clips up to 30 minutes of time per clip. So this basically is the lecture 1, and let us say it is lecture 1.1. So the first 30 minutes for the first lecture, and the second video would be lecture 1.2 and so on. So this is each lecture basically is of 90 minutes duration until we meet on campus. The on-campus schedule may be different.